Hello everyone and welcome back to Apio Puzzles, and a bit of a different one today. Normally on a Saturday morning I like to bring up the Saturday paper and solve the cryptic from Liam Runnels. However, this morning, unfortunately for a Saturday paper, their website is down, so I couldn't do that. And instead I brought up this Sudoku that I saw a few days ago, which caught my attention because it's called Bank Shot by Math Pesto. Math Pesto, very well known and popular setter of Sudoku, and a bank shot is a shot in pool or snooker, which are two sports that I both play and love. And a bank shot is basically when you hit the cue ball against a cushion before making contact with eventually an object ball. And this puzzle plays on that idea a little bit, although you don't need to know pool rules to get going with it. So I will leave a link in the description if you'd like to give it a try yourself, and I'll explain the rules. The rules look a bit bewildering, but they're not, so let me explain. So we start off with basic Sudoku rules, which is that the digits 1 to 9 must appear in every row, in every column, and every 3x3 box. We now have this the first X digits along the indicated diagonal sum to the clue, where X is the first digit the arrow points to. Now that sounds very weird, but let's use an example. This 18, we're saying that if there was a 5 here, for example, we'd say the first 5 digits along that diagonal must sum to 18. And if this was a 3, and it would be first 3 digits, etc. So that's as complicated as that gets. Now there's an additional rinky-dink here. So if X exceeds the number of cells in the direction, the sum bounces off the edge at a 90-degree angle and continues. And this is the bank shot idea. So the example provided is that this cell here, if that was a 4, it would go 1, 2, and then bounce back and do this. So those 4 cells would add to 31. So that is all there is to it. And we'll see how we go. Let's waffle. Now, when we're looking at variant Sudokus, we're commonly, especially with so little information apparently provided, it's usually useful to look at large numbers and small numbers because they tend to have the most limitations. So the biggest number we have is this 75. So that's going to have to kind of cover quite a few cells in order to get up to 75. And I suspect it might actually have to be 9. If this was an 8, we'd be saying we're going to take those 8 cells, but these 7 would have to be, so this one's 8, and so that takes us down to 67. These 7 cells would have to sum to 67, and there's not going to be any way you could do that, because you could put a maximum of 987 in there for 24. You could put 98 here, 98 here maybe. That's another 34. That's only 58 plus the 8 is 64. That's 66, whatever. It's nowhere near 75. So that is a 9. And our 75 will go the length of this. Now, that interacts with this 42 sum. So we know that the 42 goes down that way in some direction. If we put maximum values, say 98, that also influences how far it has to go. Or let's consider actually this side. Let's imagine we put maximum values here. So let's say we did 2 9s and an 8. That's going to give us the smallest possible total for over here to complete the 75, and then it'll tell us something about the 42, assuming these are as large as possible. So 9, 9, 9, and 8 are 33. Take that from the 75, so we need 42 to complete, and that would be exactly the 42. So it would have to be exactly 5 cells. Yeah, because we know that those 5 cells sum to 42. So this would be the 5. And then these would have to add to 37. And that's not possible actually, because the maximum you can do is 9, 8, 9, and 9. So that's 35. That's not enough. So that is to say that, well, that seems to say that we actually can't max. We cannot max these out. Fair enough. Feels like we can't go too low though. We are having to get to a very large total. Actually, let's consider that for a second. The maximum these can be is 24. The maximum you could put here is 8, 9, and the maximum you could put here would actually be an 8 because of this 9, and then a 9 over here, and then an 8 over here. If I did that exactly, I'd get 9, 8, 9, 8, that's 34. I'd have 24 in here, that's 58. And I'd have 17 in here. That's 75. Oh. So that's literally the maximum I can do, and that gets me to 75. Could I? Yeah, I couldn't have shifted any of those around. It was all forced. Wow, okay. Now, this one's interesting because it's part of the 42. In fact, what do I know here? I've got 17, so the minimum along this diagonal is 17 plus 8, 25 plus 7, 32. And if this was an 8, that's not going to work. 33, 7, 40. Yeah, actually you can't, I don't think you can do that. You can't do this because this would be a minimum 8, but now we've got this 42 clue to contend with, so we've got 15, 23, 32, 40, and we'd need 3 more cells that sum to 2, and you can't do that even with just ones. So if I put, well, maybe this has to be a 7. If it's an 8, I think it just must break, because you'd have at least these 3 cells. They're at least 3, so these would have to add to 39 at the most. We've already got 17 there, so you'd need 22 for these 3. That would be an 8, and you'd have 14 for these 2, and you can't do that because you've only got 7 and 8 minimum. So that means this is a 7. Now 7 cells means that these 2 are in, let's call this another color. So we've got 24. We've got minimum 2 8s there for 16, makes 40. So the maximum these can add up to is 2, which is also the minimum by putting 2 1s. So to put another way, if I put a 9 in here, so increasing it, instead of 8 8 we put 9 8, we're going to get 34 41, and these would have to add up to 1, and that can't be done. So these are 1s, these are 8s, and these are both 9s because they can't be 8s anymore. And what we should get, yeah, that just should all work automatically now, I think. So 7, 15, 23, 32, 40, 42, and this one is the same set of digits we started with, just the maximums. And there we go. So we have a start. Now I'll just do some Sudoku quickly. There's a 9 in one of those. There's an 8 in one of those. There's an 8 down there. That probably can't be an 8, but we'll come to that. And that's about all we know. Now, do any of these arrows actually, if this was only 3, this would have to be 9, 8. That can't be because of this. So this must be bigger than 3. So it's 4 or greater, and it's going to definitely take in that cell. If it was just 4, that would be 12, and these would have to add up to 8, which would mean that was not a 9. Oh, in fact, that can't be a 9 because you've got 4, 9, 8. That's already breaking the 20 total. So that's not 9. That's a 9. And we have a 9 down here. In fact, that can't be 7, 8, or 9. So that's a maximum of 6. But it could be much smaller. Not sure about that just yet. This 7, 8, 9 means this value here is... Yeah, this can't be a 5 surely. So you'd have the maximum you could put here would be 4 and 6 because of the box, and that's giving you 15, and you need these two to add to 18, and you can't do that in any case, especially if you've already got 9, 8 used. So that has to be 6 and has to be using all of these. In fact, it might just be a strict minimum kind of situation again, so, or maximum rather. This is a maximum of 5, 6, 7 for 18, and this is a maximum of 4, 5, 6 for 15. 18 and 15 is 33. Right. So we're left with 1, 2, and 3 in the box. We're left with 1, 2, 3, and 4 in here. There's no 1 in there. This is part of this. Oh no, it's not. I was going to say it's part of this for clue, but no. Now let's remember this could be bigger. It's just a minimum of 4. Well, it can't be 8 or 9. It's got an 8 in it, so if that was 7, obviously that's not going to work yet. So there's a limit on how big this can get. If it's a 6 and an 8, that's 14, and I'd need 4 more cells. That might work actually, because you could do 1, 2, 1, 2, or something like that. So I just double check 7 now. I say that 15. No, you need 4 more cells, something to 5. They'd be at least 1 and 2 for 3. You'd need. Oh, you could have 1 and 1. Oh, I think that might work. If I go 7. Except, hang on, no, I can't do it. There's ones here. So in fact, this is a 1 by Sudoku. So these 2 digits are now a minimum of 2, 3. Let's go off this basis. So if this was a 7, you'd have 7 plus 8 is 15 plus 5 is 20. It'd already be there, and you need more cells. So that's no good. And it's going to be even worse because 6, 14, 19, you'd need 2 more cells, something to 1, 5, 10, 18, you need 2 more cell, 1 more cell, something to, so you could have a 5. So that's a 4 or a 5. Now, how much bigger can these get? If this is 4, 12, then these have to add up to 8. So it could be 2, 6, or it could be 3, 5. If this was 5, 13, minimum of 5 here, 18, so you'd have, this would be a 2. Okay, maybe that's not that fruitful. Let us consider some other things. So this one, for example, has to be at least a 4. So a 3 would mean that these two had to sum to 22, so that's not possible. But a 4 would mean these 3. The maximum that is 3. So 4 and 3 is 7, and I need these to add to 18, which is not possible. So this is at least 5. Again, these are minimum 2, 3, but that's not that relevant. Well, maybe even 5's not possible. 5, 5, 3, that's 13. You need these to add up to 12. Oh, and they couldn't be, because 12 is either 9, 3, 8, 4, or 7, 5. What if that had been a 4 though? 9, 3, so 12, so these being 13, then you could do 6 and 7. Interesting. Is that where I'm supposed to be looking? This digit here, 27, that's going to have to be pretty big as well, because it's going to take in these two cells. So if it was only 4, 4 plus 3 at a maximum, that's 7, and then these we have to add to 20, so that's not, it's got to be at least 5. It can't be 6, 7, 9, or 8, so that is a 5, which means this is a 4, 12, and these do add up to, so this is going to do this, and these two add up to 12, so these have to add to 8, but they can't be 3, 5, so they are to 6. And we're left with 3 and 7. And this is a 5-cell thing, so let's give that a color. There's a lot of overlapping colors here. Now then, maximum 5 plus 7 is 12, plus 3 is 15, so these have to add up to at least 12. Neither of them can use 9 or 8, so the maximum they can be is 7, 6, and the minimum they can be is 7, 5, so there's definitely a 7 on there, because these have to add up to at least 12. So they're either 12 or 13, which means that this can't be a 3. 5 plus 3 is 8, plus 3 maximum is 11. These have to add to 16. So this is a 7, this is a 3. Get rid of the 3 there. And I think this will change depending on this. So if this is 7, 6, 13, 20, 25, that becomes a 2. But 7, 5, 12, 19, 24, that would have to be a 3. Right. So it is 7, 6. And this is a 2, that's a 1, that's a 3. This 6 has put a 2 there. 6, we get 5 and 4. This is all just by Sudoku. 6, 7 over here. 2, 3, and 5 in there. And 1, 4, and 8 up there. No 8 in the middle. Okay, so all sorts of things going on. So let's look at this one now. If that was 5, you'd have 9, 11, and these would have to add up to 14, and they can't because 9, 5, and 8, 6 are available. So this must go further, must go at least 6. So it's going to be those digits, which is 15, and these have to then add up to, would have to add up to 10. And they would have to be 3, 7 if that's the case. But it could it go further? 7 going to this cell. So we had 7, 9, 13, 16, minimum of 2 for 18, allowing us 8 in here. That seems possible actually. So that's a 6 or a 7. Let me quickly have a look. Well, this 18 here is not starting with a 1, so it starts with a 4. And it's going to be 4 and 5, which is 9, so these two digits have to add up to 9. So this cannot be a 5. So 5 in one of those. So we're either going to have 2 and 7 or 3 and 6. And that is a line there. Never seen so many overlapping colours. I could have actually used lines rather than coloured backgrounds, but ho hey. Oh, that's 7 there, sees that. So that is a 6, and that's a 3, and that's a 7. And that's great. So we've done a whole lot of these clues. I think it's just the ones at the bottom now, which, and this one. So now that this is a 3, 3, if this was a 7 over here, you'd have 6 plus the 7 is 13, 17, 19, and these would have to add to 6. They couldn't be 1, 5, so they'd have to be 2, 4, which works. It would be this direction. If this is 6, 15, these then have to add to 10, and they had to be 3 and 7, which is only possible in that direction just by Sudoku. So that's how they are going to work. This is not a 6, this is not a 7. I feel like this in Sudoku I can probably do like ones, no? Maybe not. Okay, so let's consider this here. What are the actual values left for this column here? Let's get rid of that 8 and just say 2, 7, 8, and 4. So clearly 2 is no good. 4 would mean these had to add up to 27, which is impossible. You'd need 3 9s. So it is a 7 or an 8. Holy cow, that is a lot. I suspect that means this. Well, let's see what that incorporates. Well, it's at least those. So add some more colours to the mix. I'm running out of colours. Let's make it black, grey maybe. It's at least those. Surely it can't go 8. If it did, it would be 3, 5, and 6. It's 14, plus the 8 is 22. And I need these to add to 9. The minimum this can be is 2, 3, because of the 1. And then I need 4 more, which could, no. Yeah, 3 there and 1 there. Wow. But can this ever be a big digit? It wouldn't be in the case of actually, if that's a 7, that's a 6, and this became the small number, no, the large number. I'm just wondering if this is the 2, 3 that I suggested, the minimum for when you had an 8, that 2 would make this a 7 and this a 6. So you'd have 6, 15, 22. This would be a 3. Yeah. So I can see this in my mind, but if this was an 8, then to minimize, we'd have 8 plus 3, 5, and 6. So that's 22, and we'd need these to add up to 9. Now, as it stands, we can't put 2's in either of those. I think what I thought was that, yeah, if you made this anything but a 2, I think it's a 4, and this was a 2, you would need these to sum to 3, but they can't because this has a 1 and a 2 looking at it. So the only way this would work is if that's a 2, but that makes this a 7, this a 6, and because of this diagonal, this then becomes a 3. And now this cell can't be a 1, 2, or 3, so it's a minimum of 4, and I think that breaks. So we'd have 8, 14, 18, 20, 28, and we need these two to sum to 3. This would have to be a 1, because it can't be a 2, and then this would have to be a 2, but it can't be. I wonder if there's a more concise way of explaining all that, but the point is that this therefore cannot be an 8 with a 2, 3, or a 2 whatever, so this is a 7. That's probably, and that gives us a 2 here. Now I think that was a specific case. It might have been where you had a 7, 13, 17, 19, 2 and 4, that's right. And if this was a 6, you'd have 6, 8, 10, 14, 17, and this would have to be an 8, which it can't be. So this is a 7, and this is a 4. Okay, now let's take a second to consider Sudoku. That's not a 4. That's not a 2. So this is now 7 long, and it includes 5 and 6 for 11, 18, and maybe I should do more Sudoku. But yeah, 18, we need these to add up to 13. So, well, this has a minimum value now of 3. This could still be a 1. That could be as low as a 2. Interesting. So let's consider this box here. It still needs 3, 5, and 6. It's probably just simple Sudoku actually. That's not a 6, so there is a 3 in there. That's a that is just a 1 or a 2 because it's either 3 and a 5. That's a 1, 3, 5. But I was thinking about this because of this here. So it's got to get to quite a large number. And the largest this can be 5 plus 7 plus 2 is 7 plus 6 is 13. So then these would have to be too big. So this must go further than this box. So it must go to at least there. And it's not a 7. So it's an 8 or a 9. Oh, it's not a 9. So, oh, sorry. What have I just done? There we go. So it is an 8. Okay, so now we get our final color, I think. Let's accept that. And well, we'll go black now. Ugh, that's very hard to see the numbers though. So let's go. Let's try a different palette here. Brown. Ugh, it's not very pretty, but that'll do. Oh no, there's a nice. That's possibly. Oh, yeah, we'll do purple. So we've got 8 plus 7 is 15, 18, 20. So we need 19 more. And the maximum here is 5 and 6, which is 8. Let's do Sudoku. There's an 8 there by Sudoku. Quite often Sudoku, amazingly enough, is an essential tool in solving Sudoku puzzles. There's a 9 down, there's a 9 there specifically, and there's a 9 in here. 2, 3, 4, 5, 6, 3, 5, 2, 4, 6. That's a 2, 4 only. So that's a 2, 3, 4 triple. So that's not a 3. So that, why did I say, Why did I put 3 pencil marks there? Could have been there. Take that out. I feel like that could have been a 3. Perhaps there's some reason why it can't, but I'm not sure. In any case, we've got the 2, 3, 4, we've got the 5, 6. That's fine. There is a 3 in here because of that triple. So that's not a 3 and that's not a 3. We've got a 1, 2 pair there now, so that's not a 1. 3, 5 pair. Now, down in this column we need 1, 2, 4 and 6. So there's still a 6 to place down here. Right. Look at this cell here. Right, hang on, why has this got a single 1 in it? Was that to do with... I was just putting minimums, I think. I'm not sure. 1, 2, 3, 4. 1, 2, 3, 4 and 5 to place. 1, 4. So this is only 3 and 5. So we get a 3, 5 just by Sudoku. So this has to be a 1, 2 or 4. It can't be a 2, so it's a 1, 4. And we get the 1, 4 and then we get this 3, 5, 6 triple. Down in this column we need 3, 5, 9 and 2. So there's a 2 down here. It doesn't seem that powerful. This is a small digit on this long clue. So what have we got again? 5 and 6 is 11, 18, maximum of, well, let's say it was a minimum 19. And then could we make this, well, it feels like we could. 2, 3, 5 and 6. So this is 2, 3, 5, 6. There's a 9 in here, along with a 3, 5 or 6. Okay, is there a clue I've not completed or one I've just not even looked at? 20's in 4, 25 is in 25, well I have done that, I just haven't coloured it. Make it light blue. Hectic. I really should have used lines. So there is a 2 and a 6 down here. Oh yeah, so there's 2 here by Sudoku, means that's a 4, 8. So if that was an 8 for 15, and we minimise 23, 24, 30, 35, yeah, that cannot be an 8. Because even if we use minimums elsewhere, we're getting too big. So that's 4, and that's an 8. That places an 8 over here. We've got 10, 18, 20. So the remaining have to add to 19. Well, if that was a 9, these would have to add to 10. Which they can't, because this the minimum you can put here is 3 and 5. So this would have to be at least, at most a 2, but it can't be a 2 or a 1. So that is not a 9. Fairly minor observation, it feels. Two in there, yeah, right. 1, 2, 4, and 6. This can't be a 1 or a 4, so this is a 2 or a 6. Ah, it can't be a 2. Why can't it be a 2? Oh, because there's a 2 in one of these. So this can only be a 6. And this is a 1, 2, a 1 or 4, because the 2's up above. What about 5? There's a 5 in there. Don't know. 7. Desperately searching for Sudoku. It doesn't feel obvious how we can use these sums. I guess we're going to have to. I feel like I'm running out of Sudoku options. Well, let's go maximums along this line. So we've got 10, 15, 17, 23, 31. So these have to add up to at least, I'm not sure I added that right, 10, 15, 17, 23, 31. Yeah, these have to add to at least 8. At least 8. They don't contain a 1 or a 6. Actually, what I think maybe I need to know what these can be. 1, 2, 3, 4, 5, 6, 7, 8, and 9's impossible. So this one here, 1, 2, 3, 4, 5, 6, 7, 8, and 9's impossible. So I said that in the maximum case, these would have to add up to 8, which they could be with a 3, 5 pair. Maybe this can't be a 7, 15, 22, 25. If we minimize the rest, 28, 30, 35. That seems... Wow. Let's come back to this one. 11, 17, 22. So these have to add to 9. Now if that was a 4, then, and this was a 5, that's already the 9, so that can't be a 4. That's good. That will be quite important, I think. I say that and then suddenly that's a 2, 3. So this is a 1, 2. The 1 gives me the 8 and the 1, which gives me the 8 down here. There's a 1 in there. Now that becomes a 4. That becomes a 1. So that becomes a 1. So now along here we need these to add up to 8. So it's either 5, 3 or 6, 2. So that is a 2 or a 3. But if that's a 5, that becomes a 3. And that would have to be a 3 as well. So that is a 6. That's a nice play. So that is 6, 2, which leaves all that alone. The 6 gives us 5 and 6. 5 gives us 2 and 5. 7 and 6. 2 and 3 from up above. That might have been around for a while. So yeah, we're closing in now. So 1, 2, 3, 4, and 7 down there. That's not 4, that's not 7. And we still need a 2 and a 9. Still placing 9s. Amazing. Yeah, okay. Now, and that's the 9. That's the 9 there because of the 2 across to the right. So that takes the 2 out of there. 2's not there. So that's a 2. That's a 9. Left with a lot of 3, 5s here, which hopefully won't be deadly. Deadly pattern is something I might explain if I remember at the end. 3, 5, 7, and 4. So there's a 4 in one of those. So we've got that complete line now. And so this line here, 15, 18, 20, 26, we need these to sum to 13. If that was a 7, we could have it with a 3. Oh no, that can't be a 7. If that's a 7, you could put 3 and 3 there, but then neither of those can be 3. So that is not a 7. That's a 7, another 3, 5 pair. They're all over the place. this must be limited now. It can't be a 2 or a 6. So we've got a 3, 5 pair again, so that's 7, and a 3, 4 for something different. Now, that had the effect of changing this setup. So they had to add to 13. So you've got 8 here. So this must be 5 to get them to add to 13. There we go. And that's going to unravel the deadly pattern, or not the deadly pattern, but the pattern that existed. And we get a 3 in the corner. Ah, sad. So this is a 5 by Sudoku. That's a 9. That's a 6 and a 5. This is a 4. Just realized that my screen is probably shaking a little bit from how I've got it positioned. This is a 6 by Sudoku. And that is the puzzle. I've got my screen a bit unusually on a surface that is, I've got a very unusual desk setup, and as I'm typing, it's moving the screen around, so I have to address that. Wow, that was a little bit more challenging than I expected. It has 2 out of 5 stars for difficulty on Logic Masters, so I thought it might be a slightly easier road, and I'm fairly sure that, like, the trick they did there with the 3s, and there was another one where I forget what it was now, those 2 affecting that cell. I think they're required. I'm not sure. They're kind of fairly advanced kind of things to notice, I think. But yeah, what a beautiful puzzle. Let me pause for 1 second. No, what I was going to do was to use lines instead of colors, just to make it more readable. So for example, you can use this line tool to do this. But the problem is that when I do a line down there, I can't do another color line over the top of it, and since there's so many overlaps, it's not going to work. Yeah, it has 176 solves in 8 days, which is quite a lot, and that was a lot of fun. So thank you to Math Pesto for this vaguely pool themed puzzle. I'm a little annoyed I haven't thought of that idea myself. I built a few snooker themed puzzles in the past, and there was one that I was working on that did have an idea to do with balls coming off the edge, but I don't think I ever completed it. So anyway, that is all an aside. Thanks again to Math Pesto. Thank you to you for watching. Do subscribe if you'd like to see more of this content, and comment if you'd like to give any feedback on the puzzle, on the format, on things I missed, or things you missed. I hope you enjoyed giving it a go yourself, and I will see you hopefully soon for the Saturday paper if it comes back up.